You need to take your table of contents, update, page 137, solving rational equations. All right, this is going to go on page 137, as you can tell, of your notebook. Now, I want to see if the answers are hidden under here or not. Yes, sir. I gave one to, let's go. Now, solving rational equations. Now, all that's going to look different now is you're going to have an equal sign. That's why it's going to be called an equation, because it's got an equal sign in it. All right. A rational equation is an equation that contains one or more rational expressions. Rational equations often have extraneous solutions or solutions that do not work in the original equation. For rational equations, an extraneous solution is a number that would make the denominator zero. Very good.
I was looking at you when you said extraneous. I thought you were about to say extra trash.
Okay. You'll notice it says example 1 on this page, and then the next page says example 2, and then an example 3. Our goal is to work through the example 3. So that's as far as we're going to get today. All right. Yeah, well, we'll try. Well, I have to, because I have to keep up with Miss Ulaga. We've kept up with her all semester. Not going to blow it now. All right. Okay. Now, if you didn't see the equal 7 part, what would you be inclined to do? You would be inclined, I hope, to factor and see if you can simplify. That's what we're going to do. How does that numerator factor? Good. It's a difference of 2 squares. So that's x minus 3 times x plus 3. Now, what do you see? Well, you see the x plus 3's will factor out. So you get x minus 3 equals 7. So x is 10. Now, listen. When it says extraneous solution, it means you've got to check and make sure that that thing works. Now, you can do this in your head. I'm not going to force you to write it down. If we let x equal 10, 10 squared minus 9 divided by 10 plus 3. Now you should have a calculator. Is 91 divided by 13 equal to 7? So this is your answer. Circle it and move on. Shh. Now, gentlemen, now let's look at B. Same idea as what we just did. If we didn't see the the equal 5 part, you would factor and see if it will simplify. That's right, Eli. How do you factor that numerator? Exactly. Now, have a look. What do you see? X plus 4 equals 5. So x equals 1. Now, we have to check them. If x equals 1, what's going to be 0, so what doesn't work? Oh, here's what Aiden saw. Aiden saw that denominator, if x equals 1, what's that denominator? 0. And what happens if I divide by 0? I can't. So here's what you're going to do. You're going to just make one mark through that. Don't gouge it out. But no solution. Why? Because the only possible solution I got, if you let x equal 1, 1 squared is 1, plus 3 times 1, right? Minus 4 divided by 1 minus 1. That's 0 over 0.
That's 1.
That does not equal 5. Don't even. That is not 1, and don't even start with me. Well, fine. 1 doesn't equal 5. Okay. Next problem. C. What are you going to do first? Factor. Factor. Go. How does that factor?
X plus 4 and X.
No.
Oh, minus 3.
Yeah.
I'm tired.
Hey, don't use mics.
Here we go. I can factor these out. So what am I left with? I'm left with x minus 3 equals negative 7.
So it,
So x equals negative 4.
But it's a no-no.
Why is that a no-no?
Because X can't equal negative 4.
Because, good, because if x equals negative 4, that denominator is 0. So you're going to, once again, no solution.
does that mean that you could like technically just pick up butter and
Listen to me. If you don't show me this work, I will give you no credit. Period. Period. End of, there's no discussion here.
No.
Now, here's what you got to understand. What that means is this thing right here will never, ever equal negative 7. Ever. No way. D. Yes, that numerator is a difference of 2 squares. 2x plus 3 times 2x minus 3 over 2x plus 3 equals 5.
Do you see how at least one of them?
So 2x minus 3 equals 5. Can you solve that equation in your head?
Yes.
X is 4. 8.
If you add 3 to both sides, you get 2x equals 8. Divide by 2, you get x equals 4. Now, that looks ugly. Can x equal 4?
Yeah.
What's 4 squared? 16. 16 times 4, you have a calculator. 64. 64 minus 9. 55. If x is 4, 2 times 4 is 8, plus 3 is 11, and 55 divided by 11 is 5. There's your answer. Good. Oh, stop it. Stop it. You can use cross multi. You can use cross multiplying when each side of the equation is a single rational expression. Folks, you can only, quote, cross multiply if you got an equal and you got one fraction on each side. Now, I am not going to do this one first with cross multiplying. We are going to do this a different way. Now, here's what you are going to do. We're going to get a common denominator. Oh, stop it. What's the common denominator is 3x. Good. Now, in this fraction, 8 over x, what does that denominator need? It needs a 3, so you're going to multiply top and bottom by 3. What does the right side need? So I'm going to multiply top and bottom by x. Now, this gives me 24 over 3x equals 4x over 3x. Now, I need you to think about something right here. This equal means those two fractions are the same, right? Well, the denominators are already the same. So what has to be true about the numerators? They have to be the same too, so 24 has to equal 4x, so x has to equal 6. Don't get the cart before the horse. Hang on a minute. You never heard that? Don't get the cart before the horse? Because the cart has to be behind the horse. So, anyway. Now, you can always solve equations that way if you have a single fraction on each side. But keep in mind that your answer was x equals 6. There's another way you can do it. And again, it's got to have an equal. Multiply across. What's 8 times 3? Equals 4 times x. And weren't those the numerators that we just got a minute ago? Yeah, they were the numerators. Because I wanted to show you that the answer that we get doing it a way you already know how to do, I want you to see that this really is legitimate. Okay? Yeah, yeah. I have a plan. You got to trust me here. So what's x? You're not going to let me forget that one, are you? Check it. If x is 6, is 8 over 6 equal to 4 over 3? Yes, because if you divide the top and bottom here by 2, you're going to get 4/3. Question?
Can we do 8 divided by 4?
No. You.
My bad.
Yeah, just trying to what? No.
I mean, I don't want to do.
How much work is that? How much work is that? Really? Crutch. Cross multiplying is simply a shortcut for multiplying both sides by the common denominator. So, now my question to you is going to be, is this set up on number 1 such that I can use cross multiply? Is it 1 fraction equals 1 fraction? So we'll cross multiply. Now, 14x minus 70. Yep, solve it. If you subtract 11x from both sides, that's going to be 3x. Add 70 to both sides, I think you'll get 48. Now, you got to check it. If x is 16, what's this fraction here? 7 over 14. Now, you got to check this fraction. 11 over 2 times 16 is 32 minus 10. Because they're both 1/2, right. So this is your answer. Good. Okay, next one. Can I cross multiply? Because why? Because I have how many fractions on the left? 1. How many fractions on the right? 1. Okay. What do I get here? Now, be careful. 3x squared. Good. Good. There you go. No. Look here. What's the biggest exponent you see? X squared. That's called a quadratic. And if you're going to solve it, you got to set this thing equal to 0. Now, look at the x squared term. You got a 3. Is that 3 positive or negative? Positive. You do not want to move it. You want that x squared to be positive. So we're going to move the 2x and the minus 4. Yep. So I'm going to subtract 2x from both sides, and I'm going to add 4. Well done. Combine like terms. Now, don't even tell me this doesn't factor, because it does. Question or comment? Go ahead. Sure, of course. Yeah. No GCF. What's the only way you can factor 3x squared? What are your signs going to be? Now remember, when you do this, this plus this has to equal -7. 4 here? 1 here? -3x minus 4x is -7x. And then what do I get right here? +4. Good. So that's how we factor it. Now listen, you're right. If you can set these equal to 0 in your head, that's fine. If you can't, then you sit here and you write 3x minus 4 equals 0 and x minus 1 equals 0. You do this step only if you need it. What's x going to equal for that first little equation? Because you would add 4 and then divide by 3, right? X equal 4/3 and x equal 1. Now we got to say, do they work? Right, check them. Let's check the hard one first, 4/3, but you've got a calculator, right? Right, Ms. Tennant, I got a calculator. Okay, thank you, dear. Okay, let's take this fraction. If x is 4/3, that gives us 1 over -1, which is, so that side would equal -1. If x is 4/3, this side is going to look ugly. -1 also. So 4/3 works. 1's easy. Let's check 1. Let's check x equal 1. If x is 1, this is 1 over -2. If x is 1, then this is 1 over 2 times 1 minus 4. All right, 2 answers. 2 answers. Okay, we got 2 more on here. Y'all doing okay? You're tired. I'm sorry you're tired. All right, let's look at number 3. They have the same denominator. So if the denominators are the same, if the denominators are equal, then the tops have to be equal, right? So 3x has to equal 2x plus 3. So x equals 3. Why? Because if x equals 3, what happens to your denominators? So you're going to say, well, all right then, no solution. If you had cross multiplied, you would have had to FOIL, wouldn't you, some?
I was looking at it, I was like, so, and I was trying to figure out, I was like,
Let's look at number 4. You didn't work the first 3. Oh, I'm sorry. My bad. I apologize. Okay. There are several different ways you can work this problem right here. One way is you can cross multiply. Works just fine. But let's think, okay? Look at that first denominator. How? Do you see that that first denominator is a dots? So, yeah, so what if we decided, let's just get a common denominator? What would the common denominator be? X plus 4 times x minus 4, right. Now this side's already got it. Needs what? Now, let's take a look at that. What do I see about my denominators? They are the same. So just set the numerators equal to each other. That would give me 16 equals what? 2x plus 8. Can you do that in your head? What would you do? What would you do? Subtract 8, so you'd get 8 equals 2x. You'd get x equals 4. Huh? Well, snap. No solution. Now, would you have gotten the same answer if you cross multiplied?
Yes.
Yep. Oh, you mean it would have been tougher? It would have been a tougher problem if you had cross multiplied? Really? You don't have to. But if we cross multiply here, look what are we going to get? To 16, yeah. You solve that, you're going to get x equal 4. But yeah, I better. I better. I'm just saying to you, this will work fine. What would you do? What would your next step be? To the left? You said to the left, but pointed this way.
Yeah, sorry.
To the right. Your other left. Okay. You would move everything over here, factor, and solve. But isn't the other way a little easier?
Oh, yeah.
There are a lot of these problems, there's more than one way to do it. And I don't care which way you do it, as long as it's a way I have approved.
What if we find like our own way to figure it out?
Wrong.
Still get the right answer?
No, I do not want. I do not want. I figured out this way. When you go to, then you get a degree in mathematics and you get a PhD in mathematics and you have it peer reviewed, and then we have a theorem, then we have a method called the Collins method.
Too much college. I know that one.
I hear you. If we cannot cross multiply, we will use the least common denominator. Not LSD, LCD.
Oh, I thought it did say
Folks, shh. You saw when we worked that problem on the previous example where we got the x minus 4 times x plus 4 on both sides. This is the method that we used. When one side of your equation has more than one term, you got to use this method. You don't have a choice. It's the only way it'll work. Okay, let's look at number 1. That 5 doesn't have a denominator. How? Okay, good. Will any of those denominators factor?
Oh, the dots one.
Which one is the dots?
6.
The 6 is not a dots. X squared minus 1 is a dots. Okay, so I'm going to have 7 over x minus 1. Is it okay if I put plus negative 5?
Yeah.
Equals 6 over x minus 1 times x plus 1. Gosh, Nugget, it's still not that hard. What is your common denominator? X minus 1 times x plus 1. This, indeed, this first fraction, what does it need? Good. This one needs x plus 1. What does this one need? Needs all of it. Now, let me show you something. You can write x minus 1 times x plus 1 here. But if we think ahead just a little bit, I'm going to have to distribute that negative 5, right? So could we just write x squared minus 1? Yes, and that'll save us a step. What does the one with the 6 on top need? Nothing, right. All right. The hard part is done. Do you notice I have a common denominator? All three of those fractions have the same denominator. When I have a common denominator, then I can add the numerators, right? So on the left, what I have is x minus 1 times x plus 1. Now let's talk about the numerator. 7x plus 7 plus equals oh, but wait. How many fractions do I have on each side? Oh, on each side. I only have one fraction on each side, don't I? Yeah, okay. And the denominators are the same. So what has to be true? The numerators have to be the same, right? So, yeah, but that's okay because I heard somebody say let's combine like terms. So what have we got over here in this numerator? Negative 5x squared plus 7x plus 12, good, equals 6. Well, I don't want to do that at this moment. What's the biggest exponent I see? 2, quadratic. And in fact, maybe, if I have a quadratic, I sure as heck don't want that thing to be negative. So I got to set this thing equal to 0, right? No, I don't want to subtract 6. I don't want to subtract 6 because that negative 5x squared is going to stay negative. Move it the other side. Move it to the right, to the right, to the right. Yeah. What do I do? What do I do? Add 5x squared to both sides. Minus 7x. And if I minus 12, what am I going to have?
Can I just write it onto the other problem? I'm gonna write it up.
Yeah, you're going to just have to write small. Yeah. All right. You hate this. So GCF? No GCF. It's got to be 5x times x, doesn't it? What are my signs? Daggum them, so I don't know if the minus goes with the 5x or the plus goes with the 5x. So we're just going to hang on a minute. These two here have to equal 6, so what are our options? 3 and 2 or 1 and 6. So let's try to visualize. And remember, this plus this has to give me negative 7x. 3 and 2? Where's the 3 go, first or second? The 3 goes here? So that means the 2 goes here? Okay. That would give me a 10x, and that would give me a 3x. So, well, I got to figure out my signs. That's got to be negative, right? No, no. How do you solve 5x plus 3 equals 0? What do you do? Subtract 3, divide by 5. Negative 3/5. And then we say, oh, God. If x is 2, can we check 2? Man, that was a long problem, wasn't it?
Yeah.
I know. If x is 2, this gives me 7 over 2 minus 1. So 7. So this whole side would be 2. And if x is 2, right? 2? Is that what we're checking? 2? 2, 4 minus 1 is 3, and 6 divided by 3. Ha! That works. So x equal 2 works. Negative 3/5. This is where you get your calculator, and you plug it in. And I think it works. I think it works. But, well, let's see. Can I beat you if you're on the calculator? Negative 3/5 minus 1. We're having a race. I'm competitive.
Yeah. No one's doing it.
You're not doing it? Well, I wanted to race. Thank you, Jax.
Now I see.
My hands are broken.
Your hands are broken. Snap.
Yeah, paint knives. What are you talking about? Make me
Ah, I've screwed up somewhere. I screwed up somewhere. I screwed up somewhere because that's negative 75 over 8. I screwed up somewhere.
You put the answer.
No, I don't know the answer. I just screwed up. They're not equal. I screwed up somewhere.
Maybe they're not.
Maybe they have.
Oh, snap. Negative 3/5. What did I do wrong? 7 divided by negative 3/5 minus 1 minus 5. That's negative 8/5. That's negative 8/5. How in the world did I get what I got there before? That's negative 35 over 8. Aha! That's negative 35 over 8. Minus 40 over 8, which is negative 75 over 8. And that's what I got on the other side. Yeah, I screwed something up right here. It works.
Can we just skip number 2?
No. No, no, no. Yeah.
I'm like really impressed that was all those fractions.
Number 2. Okay. Let's look at number 2. This is probably going to be the last one that we do. But the others are like, numbers 3 and 4 are like these. So you should be all right, I hope. Now, 6 over x minus 3 equals 8x squared over what? Minus can I cross multiply? No, because I do not have one fraction on each side of the equal sign. So I'm going to have to get common denominator. X plus 3 times x minus 3. Good. So what is this first fraction missing? Good. What's the middle fraction missing? Nothing. What's the last fraction missing? X minus 3. Good. Now, I'm going to do this. I'm going to put plus a negative. All right. Are all of our denominators the same now? So what do I have to do with the numerators? I got to make sure they're the same, right? So I'm going to set them equal to each other. What's my numerator on the left side? Equals 8x squared plus 12x. Oh, oh. We're delusion. Okay. When I first started writing is when I lost you. That's not a good sign. 8x squared minus 4x squared. Which side do I want to put everything on? Move it to this right. This way, right? 4x squared. Good, because I subtract 6x from both sides. Say again. Not plus. I got to move it. What's the first thing you do to factor? GCF. The GCF is 2. The GCF is 2. I don't promise ever. I tell you what, use the space, and if we decide to do 3 and 4, we'll do them somewhere else, okay? Because I know, I had to write really tiny to get all this in here. Factor out of 2, what are you left with? 7. How can I factor 2x squared? What are your signs going to be? One positive, one negative. Now, when I do this and this, what do I have to get? Yeah, I have to get that. Yeah. A happy frog. Okay. All right. It doesn't factor? Yeah, it does. Yeah, it does. That gives us what? 6x minus 3x? And then there's your minus 9. Negative 3 doesn't work. Ah, x equal negative 3 will not work. Okay, hang on just a minute. Let's look at the 3 halves. Does 3 halves make any of those equal to 0? So we're fine on that one. Look, all you're doing when you check, you just got to check the denominators. You don't have to plug it all back in like we were doing. You just got to check the denominators. Now, let's look at this. Here's the question. What about the 2? Does 2 ever equal 0? No. Ignore it. Okay. We don't have time to do the other 2. I'm sorry, my tire story took that time, so I hope you're not too upset with me.